Okay, this raised bed garden is a three-dimensional object, so it should have three dimensions. The last dimension that we have to solve for is length. That is this dimension right here. We know the width and we know the depth based on the suggestions of the website, and we've marked those as 4 feet and 1 foot, so we want to know the length in feet. Now this length can be completely determined by the length of our available materials. And you can see that's 60 feet of 2 by 6 inch boards, but you know, we should probably convert that first to boards of 12 inches in height, right? Because we do want this to be 12 inches high, so we can just stack the boards on top of each other. And in fact, the website recommends if we have 2 by 6 inch pieces of wood, we just stack them on top of each other to achieve 1 foot of depth. So let's do that right now and say that this 60 feet is actually just 30 feet of 2 by 12 boards. Right? We just divided 60 feet by 2 since we stacked them all on top of each other, making them double thick. Now we have enough information to solve for our third dimension of the garden, length, and we can do that by setting up an equation about perimeter. Now perimeter is P, and P really just is the total length of all the boards that we have. So we have 30 feet to go all the way around the perimeter of the garden here, which is 2 widths and 2 lengths. So the perimeter is 2 lengths plus 2 widths, and now we can substitute in our known values to try to solve for the unknown value, which is length. So perimeter is 30 feet. 30 feet equals 2L, which is unknown, plus 2W, which is 4 feet. You can simplify that a little bit. 2L plus 8. Subtract 8 from each side. You get 22 equals 2L. Now you divide each side by 2. You get 11 equals L, or L, the length, is 11 feet. And we are again referring to this dimension right here. So our total dimensions of a raised bed garden we've determined now, based on assumptions and based on the total length of available boards that we have to use, is 4 feet in width, 1 foot in depth, and 11 feet in length. Now, the last thing that we have to do is solve for volume of the enclosed raised bed garden. Now, why we want to find volume is because that refers to the total amount of substance that fits inside that three-dimensional object. And if you remember anything about volume of a prism or cube, it's length times width times depth. Now, we make sure that everything is in feet, which it is, so we should get a volume in cubic feet. Sub in 11 feet times 4 feet times 1 foot in depth. That's length, width, and depth. If you do that multiplication, you get that the volume of the raised bed garden is 44 cubic feet, which we could also express as 44 cubic feet. Now that's the total volume of soil that we'll need, so we've completely finished the problem. We know the dimensions of the garden that I have to build out of the wood and the total amount of soil that I need to fill it with.